Hello, ladies and gentlemen. Today, we are going to be working on molar mass. All right, I highly suggest that you get a periodic table. I've attached this periodic table to your Google Drive. So would you please, or to this assignment page in Canvas. So please print it out, or if you want to, you can copy it, or just have it available because you will need it constantly. And I'm going to have a periodic table up, but it might be too small for you to see. And I'm expecting you to be able to reference it yourself. So before we start molar mass, which is mass is how heavy something is, we'll get to that in a little bit, you need to practice finding out how many atoms there are in a molecule. Now, remember, an atom is an individual atom or an individual element, whereas a molecule is a combination of two or more atoms. So let's just take a look at this here. Let us take a look. It says practice finding the number of atoms in a molecule. So we want to find the total number of atoms. So we have hydrogen. How many hydrogens do we have? We have 2 hydrogens, right? Let me write it like this. We have 2 hydrogens, ladies and gentlemen. How do you know? Well, you know because this little 2, this little subscript right here, that little subscript is saying I have 2 of that molecule right there, okay? Now there's a 1, but we won't draw that 1 when we're writing formulas, all right? So there are 2 hydrogens and there is 1 oxygen. That's what I expect from you. So let's take a look at this next one. How many carbons are there? That's right, there are 4 carbons. How many hydrogens are there? Yes, there are 3 hydrogens. Good job. And how many oxygens are there in this molecule, ladies and gentlemen? Yep, there's 5 oxygens. All right, so let me teach you how to do this next one. This next one, ladies and gentlemen, we have magnesium, and then we have this nitrate ion, this polyatomic ion. What we have here is there are these parentheses. You have this little 2 here. This little 2 means you have 2 of this whole nitrate. So let me do that again. This means you have 2 of that entire polyatomic ion, that entire NO3 package. So this is saying you have an Mg, and attached to that Mg is an NO3, and then attached again is another NO3. There are 2 NO3s attached. So again, there's a magnesium attached to an NO3 attached to another NO3. So here's my question for you. How many magnesiums do we have right here, ladies and gentlemen? We have 1 magnesium. 1 magnesium. How many nitrogens? That's the letter N. How many nitrogens do we have total? Well, it looks like we just have 1, but if you notice, that little 2 means we have 2 of those whole things, which means we have 2 nitrogens. I don't know where that came from. We have 2 nitrogens, ladies and gentlemen. And then, how many oxygens would we have? Well, we have 2 of these nitrates right here. So we have 2 of these nitrates. We have 2 of these nitrates, these NO3s, and each nitrate has 3 oxygens, and we have 2 of them, so we would have 6 oxygens total. So let's take a look down here at the bottom. How many titaniums do we have in this compound? How many titaniums do we have? That's right, we have 3 titaniums. How many phosphorus? That's the letter P. How many phosphorus would we have? Yep, we have 4 phosphorus. That is correct, 4 phosphorus. Whoops, whoops, whoops. 4 phosphorus. How many oxygen do we have, ladies and gentlemen? Yep, we have 16 oxygen, ladies and gentlemen. 16 oxygens. So what does that mean? Well, it means that's the total number. Mr. P, how did you get 16? Well, let's take a look. Remember, this compound says you have 3 of those titaniums. So you have 3 titaniums stuck together, okay? All right, I'm just going to draw it like that. It doesn't matter. And then you have 4 phosphoruses or phosphates. So you have 4 PO4s attached in there somehow. Okay, so there's another PO4. There's another PO4. And so if I asked you, how many phosphates would you have? You have 1, 2, 3, 4 phosphates. How many oxygens? Well, if you look at the number of oxygens, you can see we have 4 oxygens there, 4 more, which is 8, 4 more, which is 12, 4 more, which is 16. That is how you work out these problems. So let us continue. Now we're going to be talking about molar mass. The molar mass, it's an average. And they never say average, but whenever I ask you for the molar mass, I'm always going to be asking you for the average molar mass. But I won't say the word average. We just don't speak like that. So I'll be asking you for the molar mass of an atom. Well, very quickly, that is the symbol of the atom. That is the name of the atom. This little number 1 right here, that is element number 1 on the periodic table, which signifies the number of protons. But then the one thing that we haven't talked about yet, the number on the bottom is the mass. And mass, mass, ladies and gentlemen, is a fancy word for how heavy things are. So I'm asking you for the weight. I'm not really asking you for the weight because weight means something completely different. I'm asking you for the mass. But as far as you're concerned, if I ask you for the mass and you're thinking, how much does it weigh? That's a great thought process for you to have, okay? So the mass is the weight, all right? Now I'm asking you for the molar mass. What does that mean? That means the mass of 1 mole. So if you had 1 mole of carbon, ladies and gentlemen, what the heck does that mean? Remember, 1 mole was 6.02 times 10 to the 23rd of something. It's like asking for a dozen. So if I said, how much do a dozen eggs weigh? Or how much are a dozen basketballs? That's what I'm asking you for. I'm asking you for a dozen or whatever. In this case, I'm asking you for a mole. And a mole is 6.02 times 10 to the 23rd. So if you had 1 mole of carbon atoms, the mass of 1 mole, because molar just means mole. That's what molar mass is. If you have the mass of 1 mole of carbon, what would be the mass? The mass would be 12.01. 12.01 grams. 12.01 what? It would be 12.01 grams for every 1 mole. All right. Now, this is kind of a new idea, but we're going to measure mass, molar mass in the unit grams per mole. And you're going to write it grams per mole. But lucky for you, I'm going to allow you to abbreviate the word grams and the word mole. You're going to be able to abbreviate the word grams with the letter G, and you're going to be able to abbreviate the word mole by writing MOL. I know it doesn't seem like a lot, but that little E, we're going to use it. We're going to use these words a lot. So this is the abbreviation for grams per mole, and that is the unit for molar mass. It's kind of like, Mr. Pepper, what's the unit for weight? Well, in America, we would say pounds, right? But this is the mass for every 1 mole. So for example, carbon has a molar mass of 12.01 grams for every 1 mole. 12.01 grams of carbon for every 1 mole of carbon, because we're talking about carbon. All right. So what would be, ladies and gentlemen, the molar mass of an oxygen atom? What would be the molar mass of an oxygen atom? That's right. It would be 16. And it wouldn't just be 16, it would be 16.00 grams for every mole. But not just grams, grams of oxygen for every mole of oxygen. And we have to write it like this. You may not write a slash like that. It must be written as grams per mole. I'll take points off, sadly, if you write it like that. All right. Let's try one more. What is the molar mass of aluminum, ladies and gentlemen? What would be the molar mass of aluminum? Yep, the molar mass of aluminum is 26.98. Mr. Pepper, do we always have to use the, yes, you do. You always have to use the decimals. 26.98 grams of aluminum for every mole of aluminum. And that's how you would write the molar mass. Yes, all of that has to be there. Okay. When you're working out numbers, we're not going to be working on this because it'd be insane to do over the internet, and I'm not going to do it. When we're using numbers, you will always keep a minimum of 2 decimal places. So if you're adding a bunch of numbers and the number is 394, you will put 0.82. You will always use at least 2 decimal places. I don't care what your number is. The number is 1.73, then it'll be 1.73. If your calculator gives you a number, and you just should know how to round, they were teaching that a long time ago for you. Probably middle school you learned how to round, but I'm sure your teachers are always reviewing. So, and if you don't know how to round, I will send you a video on rounding, but I'm not going to do it now. So if the number is 3.81746, you're going to keep this much of the number right here. You have to keep 2 decimal places right here, minimum. Obviously, that 7 will round that 1 up. So the answer would be 3.82. Okay? And that's how you would work that out. All right, now let's move on. Okay? So that's molar mass. I'm going to move this up for you. What would be the molar mass of 2 carbon atoms, ladies and gentlemen? What would be the molar mass of 2 carbon atoms? Well, if you have 2 carbon atoms, here's carbon right here. Okay? You'd have 2 carbon atoms was equaling, it's going to equal 2 times 12.01. Take out your calculator. 2 times 12.01 equals 24.02. 24.02 what? Grams per mole. Grams of what? Per mole of what? Grams of carbon per mole of carbon. Again, we always want to see it like that. All right, so what is the molar mass of 3 chlorine atoms, ladies and gentlemen? Let me put that in green because chlorine is usually signified with green. There it is. What's the mass of 3 chlorine atoms, ladies and gentlemen? This one's a little bit more difficult. So what I'm going to do is I'm going to take out my calculator. I'm going to put in 3 times 35.45 equals, ladies and gentlemen, right? It says 1.0635 times 10 to the 2. Whoa, lots of information there. But 35.45 times 3 will equal, all right, so the answer that I have on my calculator is for 35.45 times 3, so that's 35.45 times 3 equals 106 point, what's it say? 0.35. So your answer, ladies and gentlemen, will be 106.35. That would be your full answer. And that's the answer we want for 2 decimal places. All right? So next, ladies and gentlemen, what's the molar mass of 2 boron atoms plus, so 2 boron atoms, okay, plus, whoops, I probably shouldn't do that, 2 boron atoms plus 3 oxygen atoms. See if you can work that one out, ladies and gentlemen. It's going to be 2 boron atoms. So each boron is worth 10.81. That's going to be times 2. And then each oxygen atom, and then we have 3 of those. I can do that in my head. That one's going to be 48.00. This one is going to be 10, and 81 is going to be 62, right? So 21.62. So let me just double check that math. 18, 80, and 80 is 162, correct. So what would be the mass of all of that? It would be because if I ask for your total mass, you're adding. It'll be 62, 8, 9, 4, 5, 6. Bring down my decimal place. The answer is going to be 69.62 grams per mole. Now, grams of what? It would probably be something that looks like this: 2 boron and 3 oxygen. So it'd be grams per mole of that compound. But we're just practicing, okay? So, fantastic. Let's move on. I don't know how much time has gone by. My clock stopped. And now, we're going to measure the molar masses of these molecules right here. Okay, so we're going to find the molar mass of water. I always tell my students they need to memorize this number. And just because I use it so often, you memorize it on your own. Well, you don't have to memorize it, but you will memorize it, okay? So, ladies and gentlemen, we want to find the molar mass of water. Now, before we figured out how to find out how many of each atom are in a molecule, this one has 2 hydrogens and 1 oxygen. So if we want to find the molar mass, it means we're going to have to use hydrogen and we're going to have to use oxygen. How many hydrogens do we have? Well, we have 2 hydrogens. So 2 hydrogens is going to be 2 times 1.01. And then we have 1 oxygen, which is 16. 1 oxygen, 1 times 16.00 equals 2.02 plus 16.00 is going to equal 18.02 grams of water per every 1 mole of water. And that, ladies and gentlemen, is the molar mass of water. Okay, it's going to be 18.02 grams of water for every 1 mole of water. Now, what I'd like you to do is work out this next one by yourself. So this one has 4 carbons, 3 hydrogens, and 5 oxygens. What is the molar mass of this molecule right here? Please calculate that. All right, so the answer would be 131.07 grams of this compound for every 1 mole of this compound. Mr. Pete, show us again, how would you do that? Well, you'd work it out like this, all right? You would say you have, in this case, it would be 4 times 12. So you'd have 12.01 times 4. Hold on, let me do it this way for you. Let me see. No, I'll just do it for you this way. It'll be fine. Then you have 3 hydrogens, which is going to be 1.01 times 3. And then you have 5 oxygen, which is going to be 16.00 times 5. Okay, that's going to equal 48.04. This one's going to equal 3.03, and 16 times 5 equals 80. Total that up, it's going to be 131.07. And that's where we get these numbers from. Okay, again, that's going to be the carbon, the oxygen, and the hydrogen. That's where we got our numbers. All right, so let's keep going. Let's try a couple more. Okay, so this one, okay, we have this magnesium nitrate compound, okay, and this titanium 4 phosphate compound, all right? So what do we have? You know that we have 1 magnesium, 2 nitrogen, and 6 oxygen. How do we know that? Because earlier in the lecture, this is going to be 2 of those whole things. So it'll be 6 oxygens and nitrogen. So how much would we have? Well, here's our compounds right here. We have magnesium, we have nitrogen, and we have oxygen, I mean. So let's work all those out. Please, let me show you how that would work, okay? Okay, so if we take a look, we have 1 magnesium. You can see right here, we have 1 magnesium, okay, and that weighs 24.30. We have 2 nitrogens, all right, and we have 6 of those oxygens. So how would we work that out? We would work it out like this. So you'd work it out like this, and you'd say what? You have 1 magnesium times 24.30 equals 24.30. And then you have 2 nitrogens, each weighing 14.01 equals 28.02. And finally, with the oxygen, you have 6 oxygens times 16 equals 96. Now all we have to do is add up those three numbers. So if we add all these numbers together, what we would get is we get 148.32 grams of this magnesium nitrate per, okay, 1 mole of magnesium nitrate. That would be the answer. That's the answer that we're looking for. So let's take a look at this next one here, this titanium phosphate molecule, okay? So let's look at this titanium 4 phosphate. And we're gonna do the same thing. Why don't you try to calculate it right now, all right? So hopefully you were able to calculate this compound, but I'll work it out for you anyways. You have titanium, which is right here. Each one weighs 47.87. And you have phosphorus. Each one weighs 30.97. And the oxygen, each one has a mass of 16. See, I just heard myself. I just said weighs, but it's mass, okay? So I misspoke there. So, but generally speaking, so that's what it is. So what do we have? Well, we have what? 3 titaniums. So 3 times 47.87 equals 143.61. So 3 titaniums weigh 143.61 grams per mole. For phosphorus, ladies and gentlemen, it's going to be 4 of them times 30.97 equals 123.88. Then we take the oxygens. Each oxygen weighs 16 grams, or has a mass of 16 grams, I apologize. And 16 of those, ladies and gentlemen, 16 times 16 equals 256. You're going to take all these numbers and you're going to add them together, and you're going to get 523.49 grams of this titanium 4 phosphate per mole of this titanium phosphate. Okay, so ladies and gentlemen, there you go. Enjoy. Okay, that wraps us up for today. That's telling you how to find the molar mass, and I think that's going to be it. If you have any questions, please remember I'm right here. Please go back and review the video. If you're struggling on how to figure out how many oxygens or hydrogens, I did that at the beginning. If you're struggling on where to find molar mass, I did that in the second section. And if you're struggling on how to actually put all these things together, I did it right here in the third section for you. So I hope you do well. Have a good night or have a good day, and I will be here if you need me. If you'd like to, you can, yeah, just whatever. Ask me for assistance.